Hey everyone, ever wonder what makes your cool gadgets tick? Chances are there's a tiny hero inside called a MOSFET. What's a MOSFET, you ask? Think of it like an incredibly fast, tiny electronic switch. It doesn't have moving parts like a light switch on your wall. Instead, it uses a little bit of electricity to turn a bigger flow of electricity on or off. MOSFET stands for metal oxide semiconductor field effect transistor. That's a real mouthful, isn't it? So, we just call them MOSFETs. They are super common and super important in the world of electronics, lurking in more devices than you might imagine. Their ability to switch power efficiently makes them indispensable. So, why should you bother testing these little guys? Well, like any component, MOSFETs can sometimes fail. They can get zapped by static, or they can wear out from use, or maybe a project didn't go quite as planned. Oops! A broken MOSFET can cause your favorite drone to crash, your computer to stop booting, or your awesome DIY robot to just sit there. Testing helps you pinpoint the faulty part. This saves you a whole lot of head scratching. It also means you save time and money because you won't be guessing and replacing perfectly good components. Knowing how to test is a fundamental skill for any electronics enthusiast. You'd be surprised where these MOSFETs hide. They are the unsung workhorses in so many everyday devices. Your computer's power supply? Packed with them, switching power at incredible speeds. Those cool electric scooters and bikes? MOSFETs are controlling their motors. Even high-fidelity audio amplifiers use them to deliver crisp, clear sound. Because they are so widespread, learning to test them is an incredibly useful skill. It can help you repair broken electronics, build your own amazing projects from scratch, and understand a bit more about the magic happening inside your tech. It's like having a secret decoder ring for circuits. Now, there are two main flavors of these MOSFETs, N-channel and P-channel. They basically do the same job switching, but they are turned on and off in slightly different ways, using different voltage polarities on their control pin, the gate. Understanding the difference is key when you're designing circuits or replacing parts. Testing a MOSFET not only tells you if it's good or bad, but the method can also help you confirm its type if the markings are unclear, or if you just want to be absolutely sure. This is super handy when you're salvaging parts or troubleshooting a mystery board. Alright, to test these MOSFETs, you don't need a giant lab full of expensive gear. Your main tool for this mission is a trusty digital multimeter, or DMM as we call it. This amazing device is your window into the electrical world. It measures things like voltage, current and resistance. For testing MOSFETs specifically, we'll primarily use its diode test mode. This mode often has a little diode symbol on the DMM's dial. Some DMs might also show it as a continuity mode that also measures diode forward voltage. Alternatively, the resistance mode, that's ohms, can also be used, though diode mode is generally preferred for this task. While the DMM is the star of the show, a few other items can make your life easier. An anti-static wrist strap is a really good idea. MOSFETs, especially their gate terminal, can be quite sensitive to static electricity. An anti-static strap helps protect them from accidental damage. Small jumper wires with alligator clips on the ends are also super helpful. They let you connect your DMM probes to the MOSFET's tiny legs. A breadboard can also be a great pal, holding the MOSFET securely in place while you perform your tests. Now, about your DMM. It doesn't need to be the most expensive one on the market, but it should be reasonably accurate and reliable. For beginners, a DMM with an auto-ranging feature can be very convenient. This means the DMM automatically selects the correct measurement range. One crucial tip: always make sure your DMM's battery is good. A low battery can lead to inaccurate readings, which can send you on a wild goose chase. A quick battery check before you start can save a lot of frustration. So, where can you find these tools of the trade? Your local electronics hobby store is often a great place to start. They can offer advice too. Online retailers have a massive selection of DMMs, anti-static gear, and everything else you might need. Remember, you don't need to break the bank to get started. The goal here is to get your hands dirty, learn something new, and gain the confidence to tackle your electronics projects. You can always upgrade your tools as your skills and needs grow. Alright team, this is where the magic happens. Let's get down to actually testing these MOSFETs. The very first, absolutely critical step is to identify the MOSFET's pins. Most common MOSFETs have 3 pins: the gate, the drain, and the source. Getting these mixed up will lead to confusing results, or you might even damage the component. The best way to identify them is to look up the MOSFET's part number online. You'll usually find a data sheet, which is like the instruction manual for that specific component. It will clearly show you the pinout. Seriously, don't guess the pins. First up, let's tackle an N-channel MOSFET. Grab your digital multimeter and set it to the diode test mode. This mode usually shows a little diode symbol. First, connect the DMM's black, that's the negative or COM probe, to the MOSFET's drain pin. Then connect the DMM's red, that's the positive probe, to the MOSFET's source pin. You should see a voltage reading on your DMM, typically between 0.4 volts and 0.9 volts. This reading is from the MOSFET's internal body diode, and it's perfectly normal. Now, to turn the MOSFET on, keep the black probe on the drain. Momentarily touch the red probe to the gate pin for just a second or two. After charging the gate, move the red probe back to the source pin. The DMM reading should now be very low, close to 0 volts, or your DMM might beep if it has a continuity feature. This means the MOSFET is on and conducting between drain and source. To turn it off, briefly short the gate and source pins together. A small wire, or even the tip of your metal screwdriver can do this. Test drain to source again, with the black probe on drain and red probe on source. The reading should return to the initial body diode voltage. The MOSFET is now off. Next, let's look at P-channel MOSFETs. The testing procedure is very similar, but a key difference is that the polarities of your DMM probes for some steps will be reversed compared to the N-channel test. Always keep your DMM in that trusty diode test mode. For a P-channel, connect the DMM's red probe to the MOSFET's drain pin. Then connect the DMM's black probe to the MOSFET's source pin. You should again see that familiar body diode reading, typically in the 0.4 to 0.9 volt range. This confirms the P-channel's internal body diode. To turn the P-channel MOSFET on, keep the red probe on the drain. Momentarily touch the black probe to the gate pin for a second or two. This applies a negative voltage to the gate relative to the source. After charging the gate, move the black probe back to the source pin. The DMM reading should drop to a very low value, near 0 volts, or give a continuity beep. The P-channel MOSFET is now on. To turn it off, short the gate and source pins together, just like with the N-channel. Test drain to source again, with the red probe on drain and black probe on source. The reading should revert to the body diode voltage, indicating the MOSFET is off. So what do all these readings tell you? A healthy MOSFET is a good switch. It should clearly transition from a high resistance state when it's off to a very low resistance state when it's on, once its gate is correctly triggered. And crucially, it should switch back off when the gate is discharged. If you find that the drain to source path is always shorted, reads 0 volts or beeps constantly regardless of gate action, the MOSFET is likely bad. Similarly, if it's always open, reads all open line, and you don't even see the body diode, it's also faulty. If the gate doesn't seem to turn it on or off, that's another sign of a problem. This simple test is a powerful way to weed out those duds. Safety is absolutely paramount when you're working with any electronics, even seemingly simple components like MOSFETs. These little guys can be quite sensitive, especially to electrostatic discharge, or ESD. That's the sudden flow of electricity between two electrically charged objects, like the zap you sometimes feel after walking on carpet. ESD can silently damage or destroy a MOSFET without you even knowing it. So always handle them with care. If you have an anti-static wrist strap, wear it and connect it to a proper grounding point. Working on an anti-static mat provides even better protection for your delicate components. Another huge safety rule: always test MOSFETs when they are out of circuit. This means the MOSFET should not be connected to any power source or part of a live electronic assembly when you're testing it with your multimeter. Trying to test a component in a powered circuit can damage the MOSFET, your multimeter, or even cause a short circuit that could be dangerous. Double check that everything is disconnected and powered down before you start probing. It only takes a moment to be sure, and it can prevent a lot of headaches, or worse. Safety first, experiment second. Want to get the best, most reliable results from your testing? If you know the part number of the MOSFET you're testing, try to find its datasheet online. This document is the official specification sheet from the manufacturer. It will confirm the pinout, gate, drain source, tell you if it's N-channel or P-channel, and often provide typical characteristics. This information is invaluable. Some advanced users prefer to use a small resistor, say 1 kilo ohm to 10 kilo ohms, connected to the DMM probe when touching the gate to charge it. This can provide a slightly gentler way to charge the gate capacitance, potentially reducing stress on very sensitive gates. Finally, let's talk about a few common mistakes to avoid. Misidentifying the gate, drain, and source pins is a classic error that leads to confusing readings. Always double-check that datasheet. Using the wrong mode on your DMM is another common pitfall. Ensure it's set to diode test. Forgetting to properly discharge the gate by shorting gate to source before retesting or after an on test can make the MOSFET appear stuck on. And remember, seeing the body diode reading is normal for most power MOSFETs. It doesn't mean it's shorting. Don't be discouraged if it seems tricky at first. Testing MOSFETs, like any skill, gets much easier with a bit of practice. So grab some MOSFETs, your multimeter, and give it a go. You can do this.